What's up, guys? So in this video I'm going to be showing you some of the steric factors in nucleophilic substitution reactions. So as you can see here, we have our nucleophile and this is our carbon. It's being attached to this alpha carbon. Let's get right to it. So there's some substituents on the alpha on the alpha carbon. Okay. So there's different forms of this, as you can see, on the substrate of the alpha carbon. So there's primary, secondary, and tertiary alpha carbons. It's more of a molecular view of it. The backside of the leaving group view of an approaching nucleophile. Okay, so this is important. So if you have a primary carbon, it's least sterically hindered because it has less carbons bonded to it. If you have a tertiary, it's more sterically hindered because there's more molecules involved. As you can see, it's much more clumped up on this tertiary alpha carbon. You can see all the different hydrogens attached to the carbons. So it's more sterically hindered. These are all SN1, by the way. Oh, this is SN1, that's SN2. Sorry about that. So that's SN1, that's SN2 reaction. Okay, so substituents on the beta carbon of substrate. So you can see that there's some substituents that appear on the beta. For secondary, you see it becomes a tertiary. Yeah. All primary bromides, you can see the red ball right there. Those are the bromides. Okay. The backside leaving group and the view of the approaching nucleophile. So no beta hydrogens on this one. So there's an internal rotation over here. Effect on steric hindrance. Some conformation of beta hydrogens and tied to the leaving group for less steric hindrance. So this has two conformations. This has one conformation. This has no conformation over here. You can really tell because of the type of projection. Like you can see this one has a hydrogen covering right there, so there's only one conformation. This one has less. This has more hydrogens than this one, so there's no conformation. This one has somewhere in between, so there's two conformations. It's missing one of the carbons, so this is more of a secondary carbon right here, so it's able to have two conformations of itself. Increasing reactivity of SN2. So as you go down this line, the less number of carbons you have. So this is tertiary. That's also tertiary. And this one is secondary. So the lower number of carbons you have, the more reactivity of your SN2 reaction. The more likely it will happen. Some steric hindrance of nucleophiles. Here's an example. A nucleophile atom of oxygen. So you can see the oxygen and hydrogen and OH, butanol, butanol. So you can see the OH, it's tertiary, more in the molecular type structure. You can see there's some steric hindrance there. So you can see some steric hindrance here, because look at all those hydrogens on this tertiary butanol, and even more over here, because there's tertiary oxygen, and then you have your isopropyl group attached to oxygen. So yeah, you can tell that steric hindrance plays a big role in terms of SN2 SN1 reactions. This one has a bromine that replaced the hydroxide, that's why it's very big right here. And thanks for watching, guys. God bless.